Have you ever wondered how Java programs actually run on your computer, or why people always talk about JDK, JRE, and JVM like they are different things? So don't worry, you are not alone. These three terms are confusing at the first, but once you understand them, Java suddenly makes a lot more sense. In this video, we will break down JDK, JRE, and JVM one by one using simple explanations and examples. So by the end of the video, you will exactly know what each one does and how they work together. So it is very important to understand the difference between the JDK, the JRE, and the JVM. And if you are a Java developer, you must be aware of the Java ecosystem. So what are the components which is involved in the Java? And it is a beginner friendly topic, but fundamental topic for any interview. So let us see first of all about the JVM. So JVM stands for Java Virtual Machine. So as we know, any machine is responsible for generating the output on the basis of the input. So here you give any input, machine processes on the input and generates the output. Now the Java Virtual Machines is basically an abstract machine you cannot feel or touch like any physical machine, but it is responsible for converting an input into the output. So here input is the bytecode which is generated by the Java compiler, and it converts the bytecode into the platform specific native code. So here bytecode is platform independent in nature. Now you must be asking that what the platform is. So platform is basically a combination of hardware architecture plus the operating system like Windows, AMD 64, Linux, x86. So these are the example of platform. So as you know, our bytecode is platform independent in nature, but our JVM is not platform independent. It is specific to the platform. So for example, you have different JVM for Windows, you have different JVM for Linux OS. So the JVM is responsible for converting your bytecode into the machine specific code, after which the CPU is responsible for executing your native code. So it is also responsible for portability of your Java program. So let us see a flow of how your Java programs get executed. So here is your Java source code, which is .java file, and here is your Java compiler, which is Java C. Now this Java compiler is responsible for converting your source code into the bytecode. So this will be your class file generated or .class file. Now this class file is basically your bytecode, which is platform independent. Now after generating the bytecode, here your JVMs comes into the action. Now JVM has several components: the class loader, the bytecode verifier, interpreter, and the JIT, which is just in time compiler. So in modern JVMs, they are heavily rely on this JIT, which is just in time compiler. So first of all, class loader will load your class file into the memory. After then, the bytecode verifiers validates the bytecode which is generated through Java compiler. After that, interpreter executes your bytecode line by line, but it is a little bit slower. Then here comes your JIT. Your JIT is responsible for converting your bytecode into native code, and this native code is getting executed by the CPU. After that, this JVM has converted the bytecode into the native code, which is the binary instructions for the platform specific. So this native code is executed by the CPU. After that, your Java program is getting executed. So here is a concept in the Java, which is the Vora architecture. Vora stands for write once and run anywhere. So with the help of this bytecode, you only need to write your source code for the first time, and on any JVM you can execute this bytecode irrespective of the platform. That is how your Java is platform independent. So it is the important concept for your interviews, as well as it handles the memory management and the garbage collection. So in memory management, it is JVM is responsible for allocating objects at the runtime. So whenever you create an object, JVM allocates the memory to the objects from the heap memory, and the garbage collection is responsible for deallocating the unused resources. Whenever our objects get destructed or it is not being in the use, so JVM calls the garbage collector, and it automatically deallocates the resources. So we don't need to manage the garbage collection as we do in the C++. So it makes the abstraction of the garbage collection and the memory management to the developers. Now this is the all about the JVM. Now let us talk about the JRE, which is Java Runtime Environment. So it's an execution environment for your Java program. It does not provide any development tools so that you can develop your Java source code accordingly. So it is responsible for executing your Java programs only. So it contains the JVM and the important libraries which is required for executing your Java program. So if I show you in the diagram, this is your JVM and this is your class libraries, and these are inside the JRE. So this is your Java runtime environment. It doesn't contain any Java compiler or any tools which is required for developing your Java programs. So it is responsible for executing your Java code. If you are deploying your Java application into any server, then JRE is a must for installation and for executing your programs. Now JRE works into the three segments. First one is the class loader. Now it loads .class file, which is your bytecode, into memory. And second is the bytecode verifier, validates the bytecode. And the execution with the help of JIT compiler converts your bytecode into native code. All this functionality resides inside the JVM, and obviously JVM resides into the JRE. So this become automatically the functionality of the JRE. Now let us talk about the JDK, which is the Java Development Kit. So for any development of your Java program, the JDK is a must tool, and this need to be installed into your system. So JDK contains your JRE and the development tools such as the Java compiler and the debugger for development, as well as it contains the Java doc for documenting your Java program and the utilities such as the jar for packaging your Java program. So if you consider an example of the Spring Boot application, you can package your source code into the executable jar, which further responsible for running your Spring Boot application. Now JDK contains the JRE and the utilities such as Java compiler, which is your Java C, debugger, Java doc, and the jar utility. So this JDK is used for development purpose only, and this is the JDK, which is Java Development Kit. So it works into various steps. First of all, writing your source code. So it provides a facility to write your Java source code. Then the compilation. With the help of Java C, you can compile your Java source code into the bytecode. So this will be your .java file, and this will convert .java into .class file. This class file is platform independent, and then the execution with the help of JRE, you are able to execute your program. So this was all about the JDK, the JRE, and the JVM. Now, if I draw a summary diagram that this is your JVM, this is the JRE, and this is the JDK. So these are interconnected to each other. First, you need to install the JDK. JDK comes with the JRE and the important development tools such as Java compiler and debugger. Then JRE comes with the JVM and the class libraries which is required for executing your Java program. Now this JVM is the execution engine of your Java, which is the core responsible component for running your Java code. And it contains several components which are interconnected with each other and executes a Java program. So this was all about the difference between the JDK, JRE and JVM. I hope you learned something new from this video, and if you have any doubt, please let me know in the comment section. I would be reading the comments and providing you the answers. So I will see you in the next video.